Good morning, everyone, or good afternoon, depending on when you're watching this. This is Miss Henson. Today, we're going to look at lesson 6.5, which is just arithmetic sequences in word problems. So, a quick review first. We need to determine if these graphs are geometric or arithmetic. For geometric, that means you're going to divide backward. For arithmetic, you're going to subtract backward. You want to find the first term and the common difference or ratio. Then you're going to write the equation in explicit form, which is just your a of n equals the rest of the equation, depending on which equation we're using. So for our first one, the easiest way to organize this data on the graph is just to make a table. So we got x and y, and we'll just grab all of our points. So this first one goes over 1, up 1, so that's 1, 1. Then 2, 2. Then 3, 4. The next one is 4, 8. And the last one goes over 5, up 16. So when you're looking at your table, what do you think we're going to do? Do you think you get the same number if you divided or if you subtracted? Well, you can try subtraction. 16 minus 8 is 8. 8 minus 4 is 4. So that one doesn't work. So we can try division. 16 divided by 8 is 2. 8 divided by 4 is 2. 4 divided by 2 is 2. 2 divided by 1 is 2. So we got the same number when we divided, so this is going to be geometric. Your geometric graphs are going to have a slight curve to them. So what is a sub 1? A sub 1 just means your very first term. What is at 1? Well, at 1, we have 1. Because it's geometric, does it have a difference or a ratio? Difference means subtract. Ratio means divide. Which one did we do? We divided. So this is a ratio. And what was that number for the ratio, the value? That number was 2. So for our geometric equations, you have a sub n equals a sub 1, parentheses, your ratio, r, and then your n minus 1 goes in the exponent. So our sequence, our equation, will be a sub n equals our first term, which was 1, our ratio in parentheses, which is 2, and then n minus 1 goes at the top. Okay, second table, or second graph. Again, the easiest way to organize your data is to put it in a table. Just get all your points. So this first point goes over 1, up 5. And we're going to go over 2, up 8.
Second lunch, orange, grab and go to the cafeteria.
Then we go over 3, up 11. And over 4, up 14. And then what do you think this one's going to do? Is it going to subtract up or is it going to divide up? Well, we can try subtraction. 14 minus 11 is 3. 11 minus 8 is 3. And 8 minus 5 is 3. So we got the same thing when we subtracted. So this is going to be arithmetic. So what's your first term? What is at 1? Well, at 1 we have 5. Is it a difference or ratio? Again, difference means subtract. Ratio means divide. What did we do to get 3? We subtracted, so it's a difference. And what was that difference? A 3. Okay, then our sequence is arithmetic, so we're going to have a sub n equals a sub 1 plus your difference, then n minus 1 in parentheses. So a sub n equals a sub 1, which was 5, plus our difference, which was 3, a positive 3, and then n minus 1 goes in parentheses. Perfect. So, when we're looking at graphs of sequences, they're always going to be discrete. Sequences, you can think of them kind of like people in a way. You can't have like half a person or a fourth of a person. You have to have a whole person. Or even if, say, they're missing a finger, they're still a whole person. They're not any less of a person than you are. So that's why they're discrete. You can't have decimals. You can think of it as houses. Do you want to live in a half-built house? No, you want to live in a whole house. So we're not going to do decimals and stuff. That's all that means. Yeah, so it's just going to get, your term numbers are going to be 1, 2, 3, 4, etc. No decimal term numbers. So your term numbers are just going to be the natural numbers, 1, 2, 3, 4, etc. Your terms can be anything. Like if I decided to jog half a lap on the first day is going to be half a lap. Then the second day, if I did the same thing, I'm going to have a whole lap. Then the third day, I'll have 1.5 laps. But we're not going to do decimal days, just decimal laps. So your terms can be any real number. So your n and your a sub 1, those are separate, distinct points. All that means is when you're looking at your graph, they're not going to be connected. Like I said, we're not measuring every single decimal between these points, every single second of every single day. We are just measuring the end of each day. So this is the end of day 1, end of day 2. Your sequences are not going to have a y-intercept. They're never going to hit this y-axis because we're starting at 1. We start at the end of the first period. So they're going to start at 1, then whatever your first term is, not 0, then your first term. So it's always going to start at 1. So let's try a word problem. So we're only going to look at them with arithmetic. So all that means is we're either adding or subtracting. So Haven decided to start training for track. By the end of the first day, she jogged 6 laps. The second day, she jogged 12 laps. The third day, she jogged 18 laps. Her plan is to level out her training at 42 laps. If this pattern continues, how many laps could she jog on the 11th day? So for our variables, these are sequences, so we're not going to have x and y. We're going to have n and a sub n. So what 2 things is this problem talking about? For that, you can go to your numbers. We have 6 laps, 12 laps, 18 laps. We also have the first day, the second day, and the third day. So we have days and we have laps. Which one of them is going to be your independent? Just like x and y, we're still going to have an independent and a dependent. So which one of those days or laps is independent? Your days. Days isn't going to depend on anything. Time is going to move no matter what. So your days will always be days, months, years, minutes, seconds, any of that. That's always going to be your n. Laps is going to depend on the day. So it goes up or down depending on what day she's jogging. So for our equation, again, we're just looking at arithmetic for the whole lesson. So we have a sub n equals a sub 1 plus d parentheses n minus 1. So we have a sub n equals, what's her first term on the very first day? On the first day, she jogged 6 laps. So that's your first term. You can put it in a table too so we can organize our data. Her first day, she did 6 laps. Then we're going to add our difference. So we have to find that. On the second day, she did 12 laps. So on day 2, she had 12 laps. On the third day, she jogged 18 laps. So on day 3, we had 18. So how do we find the difference? Well, all of these are going to be arithmetic, so you're just going to subtract backward. 18 minus 12 is 6. 12 minus 6 is 6. So that's your difference. So we're going to add 6 for the difference. Then we just put n minus 1. And that's just because we're starting at 1 and not 0. So answer the question with correct units. It says, if the pattern continues, how many laps could she jog on the 11th day? Well, they gave us 11. Is that going to be n or a of n? A sub n. That's days, and days is n. So we're going to plug it in to n. So 6 plus 6, parentheses, 11 minus 1. And we can plug this straight into our calculator. 6 plus 6, parentheses, 11 minus 1. And we get 66. So this is 66, but our correct units is going to be, a sub n is laps. So 66 laps. Now, the reason it says how many could she jog on the 11th day is because of this sentence right here. Her plan is to level out her training on 42, at 42 laps, which means she doesn't want to go past 42. She could if she wanted to, if she continued her pattern, but she doesn't have to. She wants to stop at 42. That's why it says could right here. How many could she jog if she continued her pattern? So that's not going to change your answer here, but it is going to change your answer here at the bottom for domain and range. So for the domain, we want to figure out her interval. What's the lowest number? What's the highest number? Well, sequences always start at 1, so we're going to start at 1 here. But where do we stop? Her plan is to stop at 42 laps. So we need to find that.
Second lunch, blue, grab and go to the cafeteria.
The easiest way to find 42 laps, you could plug it into your equation, into a sub n and solve, or we can just go to our table. So if we go to y equals, clear this out, and we plug in our equation, 6 plus 6, parentheses, in this case, x minus 1. Hit second graph, and you can see your table. Figure out what day she hits 42 laps. So we can scroll down. And on day 7, she hits 42 laps. So that's the highest we want to go. We don't actually want to go to day 11 because she wants to stop when she hits 42. So we're going to stop at 7. This is domain. So in this case, domain is going to be n. And then these are going to be less than or equal to. So what's your subset? Think about your real number box. We have rational and irrational. Underneath rational, we have integer, then whole, then natural. 1 through 7, would those be rational, normal, everyday numbers, or irrational, like random decimals? Those are normal, and you can go back up to this box that we just talked about. Your term numbers are going to be natural numbers. It's always going to be natural numbers. And that falls on the rational side. They are integers, but we can be more specific than that. They're also whole numbers, but whole numbers include 0. And we didn't start at 0, we started at 1. That's why it's natural numbers. Okay, can you constrain it any further? Did we get every single number between 1 and 7? Or could we? Could she do on day 3, could she jog 18 laps? On day 4, does she do 24? On day 5, does she do 50? All the way up to 7. Yeah, she hits every single day in between. So that means there's no extra constraint on this. So what's the range? Range is going to be y, or in this problem, a sub n. So what's her lowest amount of laps? Well, at 1, she started at 6. So that's her lowest. What's her highest amount of laps? Remember, she wanted to stop at 42. So she does not want to go above 42. What goes in the middle for range? In this problem, y is being replaced by a sub n. So we're going to put a sub n in the middle. I know y'all can't type that in the computer. You're just going to put a n. You can't do the little number. That's fine. You can just put a n. And then you're going to have your less than or equal to signs. Now, 6 to 42, what type of numbers are those? Are those rational or irrational? Those are going to fall on the rational side, normal numbers, no crazy decimals. Then, are they integers? Integers are just regular numbers with no decimals, no fractions, any of that. Yes, those don't have decimals and fractions. What about whole? Whole is just 0 and up. Would those fall in the category of 0 and greater? Yes. Can we be more specific? Would it just be natural? Natural means no 0. Do we have 0 in these numbers? No. So the most specific category we can go to is natural numbers. And is there a further constraint? Are we getting every single number between 6 and 42? We can go back to our table for that. Did we get every single number here? No. We only got 6, 12, 18, 24, etc. all the way up to 42. We were counting by 6. So that's your difference here. These are multiples of 6. Perfect. Okay, let's try example 2. So a contractor is installing seats in an amphitheater. That's just a big old like stage type area. The first row has 27 seats. The third row has 33 seats. And each subsequent row, which means each row after that, has 3 more seats than the previous one. Find the number of seats on the 15th row. So as always, we got to start with our variables, n and a sub n, because these are sequences. We don't use x and y. N is your independent. A sub n is your dependent. So what two items are we talking about here? Go look at your numbers. We have 27 seats, 33 seats. What else do we have? The first row and the third row. So we have rows and seats. Which one of those is independent? The rows. The rows are already going to be there. The seats have to go on the rows. They depend on the rows being there. So our equation, like I said, all of these are going to be arithmetic. So we have a sub n equals a sub 1 plus your difference times n minus 1 in parentheses. So what's a sub 1? What's your first term? Well, it says the first row had 27 seats. So that's our first term. And as always, we can make a table to organize our data. Our first row has 27. They didn't give us the second row, but the third row has 33. Then it says every row after that is going to have 3 more seats than the previous, which means the fourth row, if we add 3, is going to have 36, and so on and so forth. So if we subtract this up, because it's arithmetic, you can either go off this 3, or you can subtract up. 33 minus 27 is 6. But that's not counting by 1 over here. This is counting by 2. So 6 divided by 2 is 3, which is the same 3 from right here, where it says they were getting 3 more seats. So you have two options. You can subtract up and figure that out, or you can just use this 3 more seats. And that's going to be your difference. So we're going to add our difference. And then, as always, n minus 1. So answer the question with correct units. Find the number of seats on the 15th row. So for the 15th row, is that going to be n or a sub n? Row is n, so we're going to plug into n. Sometimes you're going to have to plug into a sub n, so make sure you know which one you're looking for. 15. And then these we can plug in our calculator. 27 plus 3 times 15 minus 1. And we get 69. So what does that mean with correct units? A sub n is what? It's seats. So this, on the 15th row, we're going to have 69 seats. Perfect. Okay, so y'all can try your practice. Make sure you watch what variable you have to plug into. Sometimes you're going to plug into n. Sometimes it'll be a sub n.
Third lunch, orange, grab and go to the cafeteria.
Also want to look at one more thing with you. Pause the video and try the practice by yourself. And when you're done, come back here and I want to show you one thing. Okay, I hope you paused the video and tried the practice. I want to look at number 7 with you. I'm not going to solve it out all the way. I just want to look at it with you to make sure you don't miss something. So for 7, 14 pegs are placed on a washing line at 7 meters apart with a basket beside the first peg. Find the distance covered to collect the last peg if a person collects the pegs one by one without moving the basket, and they're going to return to the basket after collecting each peg. So the basket is going to be at peg 1, and then they're going to go out to peg 2, grab that one, and go back to the basket. Then they're going to go out to peg 3, grab that one, and go back to the basket. Then they're going to peg 4, grabbing that one, and going back to the basket. So Your pegs here are 7 meters apart, but because they're going to the peg and then back to the basket, to the peg and back to the basket, to the peg and back to the basket, they're actually going to double their distance. So it's not going to be 7. What's it going to be? I'm going to leave that one for y'all. So y'all finish that one. Good luck.